As we continue to follow the path through our switched infrastructure, we may need to troubleshoot our trunks. And in this video, we want to talk about troubleshooting IEEE 802.1q trunks. In fact, Cisco puts little emphasis on ISL trunks. Cisco used to really push the inter-switch link variety of trunking. That was a Cisco proprietary trunking type. It added 30 bytes to every trunked frame. Contrast that with a .1q trunk, we call it .1q for short. .1q trunks add 4 tag bytes to frames, and those tag bytes can identify what VLAN a frame is associated with. There is an exception to that though, and the exception is the native VLAN. A native VLAN is a VLAN that we can designate on a trunk as being untagged. Frames in that native VLAN do not get a tag. And let's take a moment and talk about some of the common troubleshooting issues that might arise as we're following the path from one switch to another switch. Switches are often interconnected with trunks because trunks can carry traffic for multiple VLANs. And let's break out our toolbox once again and start to populate that toolbox with some things to look for when we're troubleshooting a .1q trunk. First up, we might have a mismatched encapsulation type on each end of a trunk. One end of the trunk might be set to .1q, the other end might be set to ISL. That's not going to work. We might have mismatched trunking modes on each end of the trunk. Do you remember how a trunk can dynamically be established on Cisco Catalyst switches? We can use DTP to dynamically form a trunk. We can be in modes like dynamic desirable, dynamic auto. We could say that we're just trunking, no dynamic about it, we're just trunking. And if we are, for example, set to dynamic desirable, we're going to be sending DTP frames to the device at the other end of this trunk. And if that port at the far end of the trunk is set to a dynamic mode, dynamic desirable or dynamic auto, it will dynamically form a trunk. If we say that one end of a link is operating in trunk mode, that mode will also send DTP frames to the far end. And if the other end is set to dynamic desirable or dynamic auto, or if it's set to a trunk mode itself, then a trunk is going to be formed. I'll give you 2 scenarios where a trunk would not be formed. If either end of a link were set to an access mode, a trunk would not be formed over that link. We use access mode when we say a switchboard is connecting out to an end device, like a PC for example. So a trunk is not going to be formed if either or both ends of a link are set to access modes. Or both ends of a link might be set to dynamic auto. Dynamic auto does not initiate DTP frames. If it receives a DTP frame, it's more than willing to form a trunk, but it doesn't suggest it in the first place. And if you've got 2 dynamic auto ports, they're just sitting there waiting for somebody else to suggest that a trunk be formed, and a trunk will never be formed. Those are a couple of conditions where a trunk would not be formed. Another issue we could have is mismatched native VLANs. If the native VLAN on one switch is set to a 1 and the native VLAN on another switch at the other end of this link is set to 100, that could lead to an issue. Think about what would happen. If I sent traffic out of switch A and I said that on switch A my native VLAN was 1, well, since it's being sent out of the native VLAN, we would not add those 4 tag bytes to it. It would be an untagged frame. When the far end switch, we'll call it switch B, when it received an untagged frame, it would say, oh, by definition, an untagged frame is a member of my native VLAN, which is 100. We just did something called a VLAN hopping. We sent a VLAN 1 frame over a trunk, and it was interpreted as a VLAN 100 frame because the native VLANs did not match on our different switches. Something else that could prevent traffic from flowing over a trunk is we may have gone in and pruned off specific VLANs. Maybe for performance reasons, maybe for security reasons. We've said, here are the specific VLANs to allow on a trunk and do not allow any other VLANs. Now that we've reviewed some of the common troubleshooting targets for a .1q trunk, let's go out to a live interface and tackle a trouble ticket dealing with a .1q trunk. Let's assume that we have a trouble ticket telling us that PC1 cannot communicate out to the rest of the network. It's connected into switch SW1, and let's assume we've already checked to make sure that switch SW1 is learning the MAC address for PC1. We've checked to make sure that the ingress port on switch SW1 does belong to VLAN 300. VLAN 300 does exist, but we're having a challenge getting from SW1 down to SW2. We should have a trunk, and no trunk is being formed. That's what we need to troubleshoot. Let's begin by verifying that we have no trunk. We can do a show interfaces command followed by the keyword of trunk to see if we have a trunk, and no, I have no trunk on SW1. Let's start investigating why we don't. We can get a lot of information about the trunk configuration on a port by saying show interfaces, followed by the interface identifier. I'll say Fast Ethernet 1/0/13, and then we add the keyword of switch port. And let's see if we can determine from this output what our encapsulation type is. Let's make sure that the encapsulation types match on both ends of this link. It looks like our administrative trunking encapsulation type is .1Q. What about the other side? Let's go to switch SW2, and we'll do a show interfaces, Fast Ethernet 0/3, followed by the switch port keyword. And it says that our administrative trunking encapsulation is negotiate. So here we've not hard-coded it to be .1Q or ISL. We said when a trunk is negotiated, we'll negotiate with the far end. And the far end is set to .1Q, so if a negotiation were to happen, this side should be .1Q. That looks okay. And the next thing we might want to check out is the trunking mode. And here you'll see that the administrative mode is set to dynamic auto. We're willing to form a trunk here on switch SW2 if we receive a DTP frame. Let's go to switch SW1 and let's revisit this output from the show interfaces Fast Ethernet 1/0/13 switch port command. And take a moment, you might want to pause the video and peruse this output and see if you see anything that's somewhat concerning about this output. Did you notice that this side of the link also has an administrative mode of dynamic auto? Both sides are set to dynamic auto. Both sides are willing to form a trunk if they receive a DTP frame. However, neither side will initiate the formation of a trunk. Neither side will initiate the sending of DTP frames, and as a result, a trunk is not being formed. That's obviously an issue. Let's fix that. Let's go into interface Fast Ethernet 1/0/13 and let's change the mode. Let's say switch port mode. And we've got options. I'm going to say dynamic and then desirable. Dynamic desirable says, I'm willing to form a trunk if the other side is willing, and I will initiate, I will suggest the formation of a trunk by sourcing DTP frames. Let's set this side to dynamic desirable and see if a trunk forms now. The interface is going to go down, it comes back up, and let's once again issue the command show interfaces trunk and see if we have any trunks now. We do. It says that we have a trunk on Fast Ethernet 1/0/13. Our mode is desirable. We are trunking. Let's go check it out on switch SW2. Let's do a show interfaces trunk command. Here on Fast Ethernet 0/3, we're a trunk. Our mode is auto, but that's a valid combination. Auto on one side, desirable on another side. That works. Notice the encapsulation is 802.1Q, but notice the N. The N indicates that this encapsulation was negotiated. You see back on SW1, it was hard-coded. There's no N there, but on SW2, we negotiated that encapsulation type. We are trunking, but let's imagine that we're told that PC1 still cannot get out to the rest of the network. Are we convinced that everything is fine with our trunk? Not necessarily. We might want to check a couple of other things. For example, do we have a native VLAN mismatch? Remember, the native VLAN does not add those 4 tag bytes to a frame. Here, our native VLAN is 1 on switch SW2. What about switch SW1? Okay, the native VLAN is also 1. That's good. We don't have a native VLAN mismatch. But is there anything else, looking at the topology and looking at this output on SW1, that is concerning to you? Again, you might want to pause the video and come back in a moment when you think you see something that's a bit suspicious. Did you notice that here on switch SW1, we have a list of VLANs that are allowed on this trunk? We are allowing VLANs 100 and 200, but PC1, it belongs to VLAN 300. Do we have the same output on switch SW2? No, switch SW2 says we'll allow all VLANs. This tells us that we must be doing some VLAN pruning on that trunk on switch SW1. Let's take a look at the configuration and see exactly what we did. Let's go take a look at interface Fast Ethernet 1/0/13. Are we pruning off VLANs? We are. Look at this command. Switch port trunk allowed VLAN, and then we can give a list of VLANs that we want to allow over that trunk, separated by commas. And here I'm saying allow traffic for VLANs 100 and 200. I'm not allowing VLAN 300 explicitly, and therefore I'm pruning VLAN 300. That would explain why PC1 is not able to send traffic over this trunk from SW1 to SW2. because its traffic is being pruned off of the trunk. Let's fix that. Let's go into interface fast Ethernet 1/0/13, and let's get rid of that switch port trunk allowed command. I'm going to say default switch port trunk allowed, and the default setting is going to be allow all VLANs. Let's say allowed VLAN. We'll default that. Now we should be allowing all of our VLANs. Let's once again say show interfaces trunk. This looks much better. Now it says all of the VLANs are allowed on the trunk. And now we have resolved our trouble ticket. PC1 is now able to communicate from SW1 down to SW2.